Now, let's look at the key benefits of diversification that we are going to get when we are creating a portfolio. A simple way to look at is diversification means it is reducing the risk that is involved in the portfolio. The standard deviation of the portfolio or the variance of the portfolio should come down. That is what we say that we have diversified this particular portfolio. So just to understand that concept, a simple way to look at is for a variance. To compute the variance of a portfolio, we know the formula. Variance of a portfolio, we take it as W1 squared sigma 1 squared plus W2 squared sigma 2 squared, so on, let's say Wn squared sigma n squared plus 2W1 W2, the covariance between 1 2, 2W1 W3 covariance between 1 3. Like this I take all the pairs, 2Wn minus 1 Wn covariance between n minus 1 and n. This becomes my variance. So in a notation form, if I am looking at, it's as good as I'm adding up all the variances sigma I squareds multiplied by their corresponding weightage squares across all the I. Along with that, I am also adding up for all combinations for I and j except for where I is not equal to j, because if it is equal to j, it is becoming variance. So across all the j, I take wi times wj times, right, I am taking 2w1 w2 kind covariance between I and j. I can very well take it. So it's a sum of all the weighted variances and sum of all the weighted covariances. This is what is the variance of portfolio in total. Now let's take a few cases. Let me take one assumption that all the securities are independent. The returns of all the securities are independent, which means the correlation between them is zeros. All pairs of correlations are zeros, which means all covariances are zeros. In that situation, the variance of the portfolio is simply across all I am taking the Wi squared Vi. This is the variance of the portfolio. Now, let me make this portfolio equal weighted. So instead of considering Wi's, I say W1 equal to W2 equal to W3 equal to Wn. All of them are 1 by n because it is an equal weighted portfolio. So now it becomes the variance of the portfolio is going to become, now there is no more I. So it's a summation over 1 by n squared times Vi. And the other way of talking about is I'll take 1 by n out and I say sigma Vi by n. So it is basically the summation of all the individual variances divided by the total variance, the total number of securities. So it's as good as I can call it as 1 by n times the average variance. I can do that because Vi is sigma Vi is the summation of all the individual variances, dividing it by n, giving me an average variance. So average variance divided by n is the variance of a portfolio. When it is this 1, I have the securities are all independent and this portfolio is equal weighted. When I have securities which are almost independent, and I am talking about an equal weighted portfolio, all it is coming out is the variance of that particular portfolio is closer to 1 by n times the average variance. Now this is where one more extension, add so many assets to the portfolio, make n closer to infinite. So the variance of the portfolio is almost approaching zero. This divided by infinite almost is approaching zero. So what do we conclude from this? If the number of assets or securities in our portfolio is becoming larger and larger, I can make the variance of the portfolio closer to zero. That is where a diversification benefit is observed. I am able to make the variance of the portfolio get closer to zero. If we have independent assets, I can very comfortably take the variance of the portfolio zero by investing in large number of securities. But probably that is more and more of an ideal situation where all the securities are independent among themselves. Only theoretically it may be possible, very much away from practical, because in most of the time we see that some kind of correlation, generally positive correlation, is existing between the securities in a particular market. In a particular market, there is a good amount of relationship between the various securities that are operating. So it's very difficult to get and in reality the covariance or the correlation between them being zero. The most common observation is the correlation and the covariance are positive only. Then in reality I cannot make the risk of the portfolio close to exactly zero even by increasing, because I cannot get a situation where the securities are completely independent of each other. But I can very well try to come out with ways where I can reduce, create the least possible variance using the diversification. Let me just see how we can, the same formula. Now if I am looking at the variance without considering independence, it's as good as across all the I am taking Wi squared variance of I plus across all the j's where I not equal to j, I'm simply considering Wi Wj covariance between I and j. Now still let me consider a very large portfolio, right? Large portfolio and equally weighted. At least that much let me consider. Now I am not considering independent. So which means still each of the Wi's is becoming 1 by n. So at least this becomes for me 1 by n sigma across all the I, 1 by n squared Vi. This also I'll do it as across all j's where I not equal to j. This is 1 by n, this is also 1 by n, Cij. Now this becomes 1 by n squared times Vi, which means I'll take 1 by n out and I say Vi divided by n. Whereas here I'll take n minus 1 by n out and I say Cij divided by n into n minus 1. Now this is where comes, now you see here, this is the average covariance, because we get, how many covariances are we going to get? If this entire n squared, n by n matrix, if I am taking out n of them which are variances, it is n into n minus 1 covariance. I am considering both the pairs. So this gives me the average covariance. So this gives me average covariance and this is giving me the average variance. So variance of the portfolio will become average variance divided by n plus average covariance times n minus 1 by n. Now take a situation where n is very, very large, n tending to infinite. This portion becomes 0. Whereas when n is becoming infinite, this is becoming closer to 1. Larger and larger values of n, this is becoming closer to 1, which means the variance of the portfolio is becoming very close to the average covariance. So I am able to reduce the portfolio's variance drastically. The variance of the portfolio is becoming equivalent to average covariance. So individual securities wise, the total variance is going to 0 as n is getting large. But from the covariance perspective, at least it is becoming equal to the average covariances, which means I'm able to diversify drastically. Even if some kind of correlation and covariances are existing, as I increase more and more securities to the portfolio, the individual risk of the securities is completely getting diversified away. The total risk, at least the individual variance component, is becoming 0, but some portion which is more associated with the covariance part. See, if I look at this as the total risk, this is the contribution by the individual securities, and this is something that is contributed by the covariance term. What we are saying is whatever is the contribution of the individual variances, that is getting diversified away, but whatever is being contributed by the correlation between the two securities or the covariance between the securities, that portion of the risk is completely not being getting diversified. But overall, the simple message that comes out of this is I can very comfortably reduce the overall risk of the portfolio by trying to diversify my securities. But but if the correlation between them is perfect +1, there is no benefit of diversification. If I see covariance close to +1, there is nothing called diversification. But as I'm able to reduce this correlation from +1 somewhere towards this, I'm getting more and more diversification. The more the correlation is moving away from +1, the more is the diversification benefit that we are getting. So this kind of a basic understanding is very much required for us for typically choosing an optimal portfolio which can reduce the risk for a given level of return, or which can increase the returns for a given level of risk. All right.